Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present our lab 3 with the title AC high voltage measurement and monitoring. So my name is Muhammad ASYHRAFUL ABDUL RAHMAN. Second is NURUL SYAZWANI BINTI ZURAINI, and third is NURUL BINTI RAMLI. Okay, for the first section, I will present for the first section. Okay. So for the first section, as we see in the figure 1, and the figure 2 shows the electrical schematic circuit of measuring section, which is the connection begin from the termination of 100 picofarad capacitor email, which is connected by the short coaxial cable, which is the length is 40 cm, to adapter A, and then it connected to the secondary capacitive device, while adapter B is connected to another type of secondary device, and the terminal of the side of adapter B connected to the male of the P junction. Okay, at the P junction, the P junction connector, it has two sides, which is the right side is connected to the frequency converter by using a long coaxial cable, while the left side is connected to the speaker scope by using a long coaxial cable also. Okay, for the grounding, the bracket copper is attached with the 100 picofarad capacitor, and then the secondary capacitive device, and then lastly it is connected to the frequency converter SC. Okay, so for the safety rule action, we need to make sure that the coaxial cable is connected properly at the P junction and the bottom of the floor pedestal. And then secondly, we need to check the earthing switch is always touching the top electrode. And lastly, we must ensure that the vesting layout is clean and the cable are neatly arranged. Okay, so figure 2 shows the schematic for the measuring of section. Okay, that's all from me.
Okay, my name is SYAZWANI, and I will present the section 2. Okay, this is the feature and function of kit control 4.0 section. The first one is source control. The source control value can be set at the customer setup by using manual step. Source control is used to control by increasing or decreasing the value for gain for the constable, corporal and sergeant. And for the second one is primary side of the transformer progress. The primary side of the transformer value is shown in the section below. It is the inject value of the voltage and current. The third one is system monitoring of secondary side of the transformer with 8 slot. The 8 slot is appear as a numbering result. We only use the channel A for this experiment that is connected to the VM1 terminal at frequency converter. VM1 for the first 2 slot is shown below. Each of the channel has 2 slots of the system monitor. Okay, the fourth one is alarm system. The alarm is to indicate if there is a problem with the system. The moment when the red color is indicated, it will not be able to do any injection. It means that some problem exists, such as an open door. To clear the alarm, close the door and click on the reset button. then the alarm will indicate a green color, so it is in a good condition. Okay, so before run the measurement, the proper setting of customer setup need to be applied. The serial number and voltage divider ratio multiplier is as stated below. Serial number is 22341076-04 and the voltage divider ratio is 16951.1. Okay, this is the configuration for customer setup. There are two setup in the kit control, that are FC setup and a customer setup. FC setup is done by the manufacturing company. For the configuration for customer setup, the manual step has constable, corporal and sergeant. As for the constable, the gain is 0.1. The corporal has gain of 1 and the fastest step is sergeant, the gain is 10. The setup for impulse sequence setting and component setup is not our consideration, so leave as it is. The important part is calibration. We have 4 slots that are channel 1, RMS and RMS1, and channel 2 peak and RMS2. Since we only use one channel, so set the only first slot. Set the first slot to V voltage in RMS. As for the calibration, insert the divider ratio or multiplier ratio that is 19651.1 and then click the tick button to save the setting. The setting is for the secondary part or high voltage part. Okay, this is the importance of the section in picoscope. There are two series of picoscope. There are picoscope 3000 and picoscope 4000. The picoscope that is used for this laboratory exercise is 3000 series. It is different by the range of value. For the 3000 series picoscope, the range is up to 20 volt, and for the 4000 series, the range is up to 100 volt. Okay, this is the picoscope. First one is acquisition setting. For acquisition sample, the value is set to 0 to 100K. It stands for number of sampling. It means that the unit for whole duration consists of 100K point of sample. The 100K is the highest point for picoscope, so it is sufficient to visualize or do some monitoring measuring. Okay, for sampling interval, it is the accuracy of the measurement. It is the resolution between 2 points set from 5 micro to 50 micro. And the sampling interval is set to 10 micro. Next is the trigger active. It is used for triggering such as impulse. It is purposely used to capture the signal. It needs to be active to trigger the active button and set the impulse. The value of the trigger threshold also need to be set. The next one is channel. It has 4 channels, that is channel A, B, C and D. Because the real picoscope equipment have 4 channels, we need to active the channel A because we only use channel A for this lab. Make sure the channel must be activated by clicking on the button. The coupling set is set to AC coupling. And for the auto range, it is not encouraged to use for beginner learner. The divider ratio is set the same as the manual book, and the offset is set to 0. Okay, this is the AC tab. This section will show about the RMS value, RMC value in voltage and peak in voltage, frequency and total harmonic distortion. Okay, activate the channel A and click on the AC button before proceed to the testing in the data log and click on reset to start. Okay, that's all for me. Next, I will pass to NURUL to continue this presentation.
Okay, my name is NURUL. I will present for section 3. This is the value for the reference RMS and display RMS. This is the error. The error has been calculated for this experiment. The frequency used is 50 Hz. So the frequency that has been set for this experiment is 50 Hz. The output voltage is upgraded in each step by comparing the value for the reference, which is key control, and display is picoscope. When the output value is 0%, the value for the reference RMS is lower than the display RMS. There is an error about negative 43.58%. The output voltage is increased to 4.3%. There is an error about 10.07%. There is a small error which is 0.22% when the output voltage is increased to 33%. When the output voltage is increased to 68.7%, the reference value is 71.961 kV and the display value shows 70.74 kV. The error for this output voltage is 1.73%. This is an error between reference and display due to the sensitivity range of scope and coupling setting. The display at the picoscope is not accurate compared to the reference at key control. An instrument needs to be properly calibrated before and after it is used to make sure the result obtained is accurate. To calibrate any instrument is by adjusting the precision and accuracy of the instrument. Okay, in conclusion, student is able to construct the parallel AC high voltage measurement using key control 4.0 and picoscope 3000 series. The procedure for setting the key control 4.0 and picoscope 3000 series can be familiarized. The value obtained from key control reference and picoscope T3000 display can be compared and analyzed, and the error for the both result has been calculated. That's all from us. Thank you.